Welcome to The Explainer. Today we're jumping straight into a history that is just towering in its achievements, but honestly incredibly complex in its origins. When we look at the absolute pinnacle of American aerospace, whether it's the iconic F-86 Sabre jet streaking across the sky, the B-47 bomber, or the massive Saturn V rockets that powered the Apollo moon landings, we see the ultimate triumph of United States military and industrial might. But the DNA of these incredible technological leaps holds a genuinely shocking secret. You see, the foundation of this mid-20th century dominance wasn't built entirely from the ground up in American laboratories.
Okay, let's dive into this. To truly understand how the United States achieved this seemingly impossible peak of Cold War technical superiority, we kind of have to open up a historical mystery box. We actually have to reverse engineer our way back to the end of World War II and step inside the captured, war-torn laboratories of the Third Reich. It's a story of incredible scientific breakthroughs, fierce global competition, and massive moral compromises.
So, here's our roadmap for today. We'll start with the Prussian Continuum, then look at inventing the jet age and the swept-wing revolution. After that, we'll dive into pioneering space medicine and wrap it all up with the Cold War legacy. All right, Section 1, the Prussian Continuum. Right at the end of World War II, the United States made a fundamental shift in its military philosophy. Instead of relying purely on sheer manpower and mass production, leadership recognized that the future belonged to absolute scientific and technological dominance. Which brings us to this staggering figure right here, over 1,600. That is the actual number of German scientists, engineers, and technicians that the U.S. military deliberately relocated to American soil through a highly classified program called Operation Paperclip. The strategy was twofold: aggressively accelerate American technological capabilities for the looming Cold War and strictly deny the Soviet Union any access to these rare, highly sought-after mines. And the U.S. government didn't just view this as some simple recruitment drive. According to the source document, they viewed this massive transfer of human capital as intellectual reparations. It was a breathtakingly broad operation. The ultimate prize of victory in World War II wasn't just territory anymore. It was the seizure of advanced technical knowledge, effectively importing the minds that had conceptualized the very weapons the Allies had just spent years fighting. Moving right along to Section 2, inventing the jet age. Now, to understand this massive leap from traditional piston-driven engines to the era of jet propulsion, we have to look at this incredible parallel development happening at the exact same time. On the left, we have Britain's Frank Whittle, a quick-tempered, really hands-on RAF pilot who actually built his engines himself. But on the right is our key German figure, Hans Joachim Pabst von Ohain. Totally different guy. He was a warm, academic physicist who wasn't a mechanic at all. He actually had to hire a guy named Max Hahn just to build his initial model. These two men were completely unaware of each other's work, yet they both independently cracked the code of the jet engine simultaneously. Von Ohain's design, however, made it to the sky first, powering the Heinkel HE-78 back in August of 1939. Fast forward after the war, and von Ohain's journey leads him straight to the U.S. via Operation Paperclip in 1947, specifically to Wright-Patterson Air Force Base in Ohio. And he wasn't just consulting, he eventually became the chief scientist of the Aero Propulsion Laboratory. His presence was a real game changer. He basically shifted American military engineers away from pure abstract mathematics and directly into practical, world-changing jet engineering. He taught a whole generation of American engineers exactly how to think about jet propulsion. Which brings us to Section 3, the swept-wing revolution. So engines are only half the battle, right? If you want to fly fast, you have to deal with the physical resistance of the air itself. To break through the transonic barrier, that bumpy, incredibly violent turbulence right before the speed of sound, American aviation leans heavily on the brilliant mind of German aerodynamicist Adolf Busemann. Think about it. A standard straight wing hitting the air at high speed basically builds up a massive wall of drag. But Busemann realized that by simply sweeping the wings backward, you could essentially trick the air. The physics proved that the air flowing perpendicular to the wing's leading edge actually experiences a slower speed than the plane is actually flying. It's wild. It delays the shock waves and allows the aircraft to slip through the air much faster. Let's see how this builds a direct bridge across history. Busemann first proposed this concept at an academic conference in Rome back in 1935. It was validated in German wind tunnels, showing a huge 30% drag reduction. Then, when Operation Paperclip brought Busemann and his massive troves of wind tunnel data to the U.S., the impact was literally immediate. American aircraft designers practically overnight redesigned their straight-wing planes into the swept-wing icons we know today, like the F-86 Sabre, securing absolute dominance in the skies. In fact, it's a design leap that even dictates how smoothly and quickly you fly on a modern commercial jet today. Let's dive into Section 4, Pioneering Space Medicine. Now, flying at these extreme speeds and altitudes puts unprecedented stress on the human body. To solve this, the United States turned to Hubertus Strugold, who was previously the chief of aeromedical research for the German Luftwaffe. In 1948, Strugold coined this term aeropause, defining that critical physical boundary where the Earth's atmosphere ends and the vacuum of space begins. He essentially founded the world's very first Department of Space Medicine right down in Texas, laying the absolute groundwork for life support systems and the pressurized suits that would eventually keep American astronauts alive out in the void. Strugold's team developed the first space cabin simulator to test what happens when humans are basically trapped in tin cans at 25,000 feet. The sources highlight a really fascinating test in 1958 where airman Donald Farrell was isolated in the chamber for 7 days. And what they found was that the extreme psychological hostility of isolation was actually a much harder problem to solve than the physiological ones. This meticulous, grueling record of sweat was utterly crucial for planning everything from the Apollo missions all the way to future trips to Mars. Section 5, Ethics and Aerospace Superiority. We have to address the stark reality that underpins this specific branch of aerospace advancement. The foundational data that enabled these incredible leaps into the jet age and the space race did not come without profound moral compromises. The source materials document a very dark history regarding Hubertus Strugold's early aeromedical research in Nazi Germany. As the historical record explicitly notes, during his tenure, researchers conducted lethal experiments on prisoners at the Dachau concentration camp. These prisoners were subjected to horrific trials, including being locked in low-pressure chambers and freezing water, all to study the limits of human endurance at high altitudes. Following the war, the United States government found itself locked in an existential technological race against the Soviet Union. To ensure that men like Strugold could legally and practically work in American laboratories without public outcry, the government deliberately sanitized their records. Their wartime affiliations and the brutal origins of their data were obscured, reflecting a conscious decision that the strategic value of their scientific knowledge outweighed their histories. Finally, Section 6, the Cold War Legacy. When we pull all of these threads together, we see that the transfer of these specific mines through Operation Paperclip permanently and structurally altered the United States military apparatus, and the sheer, breathtaking speed of that transformation is undeniable. I mean, look at this timeline. The war ends in 1945. By 1947, these scientists are sitting at American desks. And that exact same year, the first swept-wing XP-86 takes flight, completely reimagined by German data. A decade later, the foundational space medicine trials are underway. This injection of foreign technical dominance allowed the U.S. to completely bypass years of trial and error, moving instantly from theory to world-beating reality. So I want to leave you with this final thought. The incredible heights of the jet age and the astonishing achievements of the space race are forever entangled with the dark origins of their architects. The blueprint was brilliant, but the ink was undeniably grim. It really forces us to ask, is the ultimate price of technological supremacy the compromise of our moral foundation? It's a complex, heavy history, and one for sure well worth your continued exploration. Thanks for joining me on this explainer, and keep questioning the history behind the technology.